In this module, you will dive into individual filtering and supporting technologies. You will learn how to process recordings using each technology from command line, using REST interface, and also in Phonexia browser, and learn how to interpret results of the processing. Before we start talking about specific details of each technology, here is a summary of rules which are common for all technologies. Command line applications require three mandatory parameters: configuration file, input, which can be either a single file or an entire directory, or a list file containing a list of files to be processed, one per line, and output, which can be a single file or a directory. Output should correspond to input, so if processing a single file input, output is expected to also go to a single file. If processing a directory or a list file, output is expected to go to a directory. REST API queries support following optional parameters: from time and to time, allowing to specify only a part of the recording to be processed; cache only parameter, allowing to prevent reprocessing of a recording. It means to return results only if they are already present in a cache from previous processing; and cache disable parameter, which does the opposite, forces reprocessing of the file without caching the results. Any eventually existing results cached previously are retained in the cache. For Phonexia browser, this is how the files are processed. First, upload the files which should be processed to the server, then select the technologies and their models to be applied using the toolbar buttons, and then click on Start button on toolbar to start the actual processing. Results will be displayed in the Results panel. Filtering, sorting, pre- and post-processing of audio recordings is a crucial part of audio processing flow. Filtering out recordings not meeting the quality criteria required by speech technologies can save a lot of processing power. Depending on use case, application of good pre-filtering chain can decrease the number of recordings to be processed in the final stage, for example transcribed or listened to by a human operator, by 4 or even 5 orders of magnitude. It's strongly recommended to start any audio processing flow with checking the audio quality using SQE and the amount of speech using VAD. Typically, recordings having a global score in SQE lower than 50 or signal-to-noise ratio lower than 15 decibels are not suitable for further processing, as the quality would be too bad to get any sensible results. Similarly, recordings reported by VAD to contain less than 7 seconds of net speech are not suitable for processing by SID, as such low amount of speech is not enough for reliable detection. Sorting out recordings to categories is another important step. For example, identifying language is absolutely necessary for language-dependent technologies like speech transcription or keyword spotting. Categorizing recordings by speaker's gender or age, and eventually filtering out recordings falling into categories of no interest, may again reduce significantly the number of recordings to be processed by SID. Pre-processing recordings by diarization before speaker identification would be another example. And at the end of the processing chain, recordings can be also post-processed, for example by enhancing them using Denoiser for human operators who need to physically listen to the outputs. This is how you run speech quality estimation in command line. The executable name is sqestim, and you need to provide the three mandatory parameters: -c option with path to the configuration file, then -i with path to the input file to be processed, and -o with path to the output file to be created. Other available parameters are listed when running the executable with -h parameter or without parameters. The output file is a plain text file containing a list of so-called variables representing the individual quality measures. Each variable contains a number of tokens: a value token containing the actual value, a min and max tokens representing the range, it means minimal and maximal limits for the value, a reserved str token, which is always an empty string, a score token representing the value as a percentual score, and weight token representing a suggested weight of the measure in the overall quality score. Last line of the output file contains global percentual score of the quality. The screenshot shows example of the output file. You can see, for example, the waveform clipped length variable on the first line. This variable says how much of the recording has clipped signal. Its value is 0, which means there is no clipping in this recording. The min token is 0 because the measure starts at the beginning of the file, and the max value is equal to the length of the recording, which can be found on the fourth line in the waveform length variable, and so on. And the last line lists the global percentual score. This is how you invoke speech quality estimation in REST API. The example here uses the PHX client tool supplied with Speech Engine, but the described principle is generic. Also, the example assumes that the file to be processed was already uploaded to Speech Engine and is present in its storage. Use HTTP GET method to send a request to technology's SQStim endpoint with a path parameter pointing to a file to be processed and model parameter containing a name of the technology model to be used. For SQE, the model name is default. Screenshots show the JSON response returned from the server. A result object containing version and name of the result structure, name of the processed file and technology model used for processing, and statistics array containing objects for each audio channel of the file. This example file is a single channel, so the array on the screenshot contains only single object. The object contains channel ID, percentual global score representing overall quality of audio in the channel, and a channel statistics array containing objects representing individual measures. Name of the measure, its value, and minimal and maximal limits of the value. String is currently always an empty string, and isValid says whether the value is valid, because under certain conditions, for example if recording is empty, some values cannot be calculated. So in that cases the isValid is false. More details and additional information can be found in Speech Quality Estimation section of the REST API documentation. In Phonexia browser, speech quality estimation is by default applied automatically when files are added to the server. Quality column shows the global percentual score. To display detailed information, double-click on the value in quality column. This opens the quality information pane with all measured values listed, as shown on the screenshot. This is how you run voice activity detection in command line. The executable name is VAD, and you need to provide the three mandatory parameters: -C option with path to configuration file, then -I with path to the input file to be processed, and -O with path to the output file to be created. Other available parameters are listed when running the executable with -H parameter or without parameters. The created output is called segmentation file, therefore the default extension is SEG and contains information which segments of the input file contain voice and which contain silence. As can be seen on the screenshot, the segmentation file is a plain text file containing 4 columns separated by space: a segment start time, segment end time, whether it's a voice or silent segment, and a channel number. The times are in HTK units. 1 HTK unit is 100 nanoseconds, so dividing the times by 10,000 gives the amount of milliseconds. This is how you invoke voice activity detection in REST API. The example here uses the PHX client tool supplied with Speech Engine, but the described principle is generic. Also, the example assumes that the file to be processed was already uploaded to Speech Engine and is present in its storage. Use HTTP GET method to send a request to technology's VAD endpoint with a path parameter pointing to a file to be processed, model parameter containing a name of the technology model to be used. For VAD, the model name is default, and segmentation parameter saying whether to include detailed segmentation in output or not. Screenshots on the left show the JSON response returned from server. result object containing version and name of the result structure, name of the processed file and technology model used for processing, and info array containing objects with speech length in seconds for each audio channel of the file. The example file is single channel, so the array on the screenshot contains only single object. If the segmentation parameter in REST query was true, the response also contains a segmentation array containing details about detected segments, channel ID, score and confidence of the detected segment, and start and end times of the segment, and whether it's a voice or silent segment. The times are in HTK units. 1 HTK unit is 100 nanoseconds, so dividing the times by 10,000 gives the amount of milliseconds. Screenshot on the right shows the JSON response returned from server if the segmentation parameter in REST query is either false or not included at all. In that case, the segmentation array is empty in the response. In Phonexia browser, voice activity detection is by default applied automatically when files are added. To display detailed segmentation information, first open the recording in Waveform Editor by double-clicking on the file name in File Name column. Then add VAD Label panel by clicking on the Open Label panel icon in Waveform Editor toolbar and selecting VAD from the menu, as shown on the screenshot. And then right-click on the VAD Label panel and select Get VAD from Server to load the segmentation information. The result is shown on the screenshots. Segments with detected voice are labeled in the VAD label panel. This is how you run diarization in command line. The executable name is Diarization, and you need to provide the 3 mandatory parameters plus a type of required output. -C option with path to configuration file, then -I with path to the input file to be processed, -O with path and base name without extension of the output file to be created, and -T with required output type, a segmentation or waveform. Other available parameters are listed when running the executable with -H parameter or without parameters. The shown example creates a diarization segmentation file which has a structure very similar to voice activity detection segmentation file. It's a plain text file containing 3 columns separated by space: segment start time, segment end time, and then either the word silence or an ID of the speaker speaking in the given segment, like speaker number 1, speaker number 2, and so on. The times are in HTK units. 1 HTK unit is 100 nanoseconds, so dividing the times by 10,000 gives the amount of milliseconds. Specifying waveform output type in the -T option creates separate audio file for each speaker where silent segments are removed, and another separate file containing only the removed silent segments. This is how you invoke diarization in REST API. The example here uses the PHX client tool supplied with Speech Engine, but the described principle is generic. Also, the example assumes that the file to be processed was already uploaded to Speech Engine and is present in its storage. Use HTTP GET method to send a request to Technology's diarization endpoint with a path parameter pointing to a file to be processed and model parameter containing a name of the technology model to be used. Apart from the standard optional parameters, diarization accepts also max speakers parameter, saying that the file is expected to contain up to the specified number of speakers, and total speakers parameter, saying that the file is expected to contain precisely the specified number of speakers. By default, a max speakers value of 2 is used. Screenshots show the JSON response returned from server. Result object containing version and name of the result structure, name of the processed file and technology model used for the processing, and the parameter specifying the number of speakers. And a segmentation array containing details about detected segments. Channel ID is always 0 since diarization processes monofiles, then score and confidence, which are not used, and also 0, and start and end times of the segments, and whether it's a silent segment or a speaker number. The times are in HTK units. 1 HTK unit is 100 nanoseconds, so dividing the times by 10,000 gives the amount of milliseconds. Calling technology's Diarization split endpoint using HTTP post method creates a new multi-channel audio file with each speaker in its own separate channel. This endpoint requires one more parameter target, specifying the target file to be created. To process a recording with diarization in Phonexia browser, select Diarization button in main toolbar, select Technology Model from the button drop-down menu, and then click on Start button in main toolbar to start processing. Detected number of speakers is then displayed in Diarization column in Results pane. To display detailed segmentation information, double-click on the result in Diarization column. This opens the waveform editor with Diarization label panel with labels for segments spoken by detected speakers as shown on the screenshot. Then it's possible to perform various further operations like, for example, select speaker segments by single or double-clicking on the labels, or split the recording to separate per speaker files by right-clicking on the labels and selecting the corresponding menu command. This is how you run H-estimation in command line. The executable name is H-estim and you need to provide the three mandatory parameters: -c option with path to configuration file, then -i with path to the input file to be processed, and -o with path to the output file to be created. Other available parameters are listed when running the executable with -h parameter or without parameters. The created output file is a plain text file listing the processed file and the detected H separated by space. The left screenshot shows output created by the shown example. The right screenshot shows output created by processing a stereo input file with two speakers, one in each channel, and using the per channels parameter. In that case, the output contains separate line for each channel and an extra column with a channel ID. This is how you invoke H-estimation in REST API. The example here uses the PHX client tool supplied with Speech Engine, but the described principle is generic. Also, the example assumes that the file to be processed was already uploaded to Speech Engine and is present in its storage. Use HTTP GET method to send a request to technology's HStim endpoint with a path parameter pointing to a file to be processed and model parameter containing a name of the technology model to be used. It's also possible to process voice prints instead of audio files. This is done by posting the voice print to the same endpoint instead of providing path to the audio file. More details are described in the REST API documentation. Screenshots show the JSON response returned from server, result object containing version and name of the result structure, name of the processed file and technology model used for processing, and a channel scores array containing results for each audio channel, channel ID, and scores array with age values from 0 to 99, where the detected age has score values 1 and all others have 0. In this example, the middle screenshot shows that the detected age is 40 since its score is 1. To process a recording with H-estimation in Phonexia browser, select H button in main toolbar, select Technology Model from the button drop-down menu, and then click on Start button in main toolbar to start processing. Result is then displayed in H column in Result pane. As shown on the screenshot, Phonexia browser displays the age as one of 4 categories: child, which is up to 14 years, young, which is between 15 and 24 years, adult, which is from 25 to 64 years, and senior, which is 65 years and more. This is how you run Denoiser in command line. The executable name is Denoiser and you need to provide the 3 mandatory parameters: -c option with path to configuration file, then -i with path to the input file to be processed, and -o with path to the output file to be created. Other available parameters are listed when running the executable with -h parameter or without parameters. Denoiser simply produces output audio file with noise removed. There is no other output. This is how you invoke Denoiser in REST API. The example here uses the PHX client tool supplied with Speech Engine, but the described principle is generic. Also, the example assumes that the file to be processed was already uploaded to Speech Engine and is present in its storage. Use HTTP POST method to send a request to technology's Denoiser endpoint with a path parameter pointing to a file to be processed, target parameter specifying the output denoised file, and model parameter containing a name of the technology model to be used. Screenshot shows the JSON response returned from server, result object containing version and name of the result structure, and an info object containing data about the created output file like its name, timestamps, size, and so on. To process a recording with Denoiser in Phonexia browser, right-click the file in Results pane and select Process and then Denoiser command from context menu. Then select the technology model to be used and target file name suffix and click on Process button. Selected file will be processed and target file will then be added to the Results pane. That concludes the module dedicated to filtering and supporting technologies. You have learned why filtering is a crucial part of audio processing flow. It can save processing time and power by filtering out low-quality recordings. It can sort recordings to categories for processing by language-dependent technologies. And it can pre- or post-process recordings either for further processing or for human listener. You have also learned about generic commonly valid rules that in command line you must specify configuration file, input, which can be a single file, a file list or a directory, and output, which can be a single file or a directory, and that in REST queries you may specify optional parameters to process only certain range of the recording or to either prevent or force reprocessing of the recording. Then you have learned how to invoke speech quality estimation, voice activity detection, diarization, age estimation, and denoiser in command line, REST API, and Phonexia browser. And you now understand how to interpret the results returned by the technologies in each of the interfaces. Remember to always check documentation or command line help to get more detailed info about additional options, requirements, and parameters.